Alright, today we're going to be talking about properties of logarithms. Now, if you don't know what logarithms are at all, then you're in the wrong place. Check out my last video where I gave a basic introduction to what logarithms are. Now, before we dive into logarithmic properties, let's clarify some common notation that you'll often see in math problems. Now, when you see a log written without a base, it's just assumed for the base to be 10. This is called a common logarithm, or you could just call it log because that's what it looks like. It just says log. Log 100 with no base just means log base 10 100. So log 100 is really just asking 10 raised to what power gives me 100, and that's going to be 2 because 10 squared equals 100. On the other hand, when you see ln, that stands for a natural logarithm, and this basically translates to log base e. Now, if you don't know what e is, it's basically an irrational number that's approximately equal to 2.7 something. So for example, ln 7 is really just asking e raised to what power gives me 7, and I don't know, so we just say ln 7. Now let's talk about why common logs and natural logs are so important. They can be used as tools to solve for equations with unknown exponents. Now, I know this all seems useless right now, but I promise it's going to help you a lot when it comes to properties of logarithms. Well, I'll tell you something, you're going to care more about it once we learn about the properties of logs for real this time. Alright, number 1, this is called the product rule. Now, this rule says that log base x of ab equals log base xa plus log base xb. Now this rule basically says that whatever's in the answer section, remember this is the answer section, whatever's in here, if it's a product of two numbers, meaning that it's the result of two numbers being multiplied together, then you can split it up and separate those two numbers and distribute it into that log base x, and you just add them up together and it equals the same thing. Now don't worry about the x is just there to show you that these all have the same base. So you couldn't do like log base 3 of AB equals log base 2A plus log base 2B. That's not how it works. It has to be the same base. Alright, now let's use this product rule on a question where you're going to have to solve for x. Alright, take a look at this. We got log base 2 of 3x equals 6. How are we going to get x out of there? Using the product rule that we just talked about, we can do something like this. We can say that log base 2 of 3 plus log base 2 of x equals 6. Now we want to isolate the x onto one side, so we can subtract both sides by log base 2 of 3. Alright, now how do we get x out of here? Take a second to think about it because it shouldn't take you that long to think about it. If you watched my last video, you would know that x is the answer. Now what does that mean? That means that you can put x over here, and then we know that 2 is a base, so we can write that here, and we know that this is the exponent, so we can write that up here. Is it coming back to you? Because it should be. If it's not, then go watch my previous video. So despite how ugly the answer is, we have x equals 2 to the power of 6 minus log base 2, 3. Alright, now an important step to being a genius is to not only memorize these properties, but to also know why these properties actually work. Now, why does the product rule work? As you know, in algebra, if you were to have 3 times AB, that would not be equal to 3A plus 3B. Instead, it would be equal to 3AB, and you would literally just multiply them together. You wouldn't add them together. So for logs, we have the same thing going on, but why do you add them up together? Now let me tell you something. Log base x is completely different to what 3 is. I've said in my last video that logarithms are literally just the inverse of exponents. So their properties are exactly the same as exponents. Perhaps you would remember an exponent property that looks something like this. N to the power of 3 times n to the power of 4 equals n to the power of 3 plus 4, which is just n to the power of 7. Now this is exactly what is happening up here. If these exponents are being multiplied together, how AB is being multiplied together is the exact same way of how 3 and 4 are being multiplied together. And when you multiply something with the same base with an exponent, then you just add the exponents together, just like how we're adding them together up here. Okay, let's say you did fail algebra and you don't remember this rule existing. Don't worry, I got you yet again. N to the power of 3 is just n times n times n. N to the power of 4 is just n times n times n times n. And if you're multiplying these two, you're multiplying them, and that gives us n times n times n times n times n times n times n, which is n raised to the power of 7. See, now with that out of the way, you're never gonna forget the product rule of logarithms. Now you know exactly why log base x of ab equals log base x of a plus log base x of b, because they work exactly like exponents, because they are exponents. Alright, now we're gonna do something that's the complete opposite of that. Well, kind of the complete opposite of that. And we're going to be calling it the quotient rule. Now, a quotient, in case you didn't know, is the result that you get when one number is divided by another. So, rule number 1, the product rule, product meaning a number multiplied by another number. Rule number 2, quotient rule, quotient meaning a number divided by another number. Now, the quotient rule implies that log base x of a over b equals log base x of a minus log base x of b. Alright, let's put this rule to use. I want you to solve this. Log base 2 of x over 4 equals 5. Solve for x. Now we can distribute the x over 4 into the log base 2, which is going to give us log base 2 of x minus log base 2 of 4 equals 5. Now, you don't know what x is, obviously that's why you're solving for it, but we do know what log base 2 of 4 is. Log base 2 of 4 is asking 2 raised to what power gives us 4. So it's pretty apparent that log base 2 of 4 equals 2. With this information, we can say that log base 2 of x minus 2 equals 5. Alright, I had to resize again. So now we can move the negative 2 to the other side by adding 2 to both sides. That's going to give us log base 2 of x equals 7. And so that means that x equals 2 to the power of 7. Now, let's plug that into our calculator. That's going to give us 128. So yeah, x equals 128. Now, I've already told you why the product rule works. The reason why the quotient rule works is pretty much the exact same reason, just with the other properties of exponents regarding division. Alright, last rule. We're going to be calling this one the power rule. Now this rule implies that log base x of a to the power of b equals b log base x of a. So basically, it says that you can move this exponent to the front here. Alright, let's talk about it. Log base 3 of x to the power of 4 equals 12. I want you to solve for x. According to the power rule, we can put this 4 to the front, and then we have log base 3 of x equals 12. We can divide both sides by 4, which leaves us with log base 3 of x equals 3. Now this means that 3, which is from this 3, to the power of 3 equals x. So therefore, x equals 27. Alright, now that's some pretty simple stuff, but I am going to be talking about why this rule exists and why does it work. Now it might seem crazy, but this, again, has everything to do with exponents and the properties of exponents. So, let's say that you have 2 to the power 4 squared. Now this would be equal to the two exponents being multiplied together, so you get 2 to the 8. Alright, so why does this work? Let's grab 2 to the 4, for example. This expanded is just 2 times 2 times 2 times 2. It's 4 2's multiplied together. This 2 tells us that there's 2 of these 2 times 2's times 2 times 2's. So we're going to have 2 times 2 times 2 times 2. So we're going to have 8 2's multiplied together. And what is that? That's literally just 2 to the power of 8. So that's why when you have an exponent being exponented by another exponent, you just multiply the exponents. So although this may look a little different from what we're looking at in terms of the power rule, it's exactly the same analogy. And I can show you why they are so important when it comes to solving equations. Alright, so what is going on here? We got 2 to the power of x plus 3 equals 5 to the power of 2x. Alright, now we can just put a log in front of both of these because it doesn't really matter what you're doing to the numbers as long as you're doing the same thing to both sides of the equal sign. You're good. Like, you're not interfering with the equation. So that's why we're allowed to add logs on both sides. And also, the only reason why I'm writing natural log instead of the common logs is because common logs would mean that you would need to write 3 letters instead of 2, and natural logs you only need to write 2. That's really all there is to me writing natural logs. Anyways, congratulations, you just made the equation look even more complicated. But according to my calculations, the product rule says, or sorry, the power rule says that we can put these exponents to the front. So let's do that. We have x plus 3 ln 2 equals 2x ln 5. I don't want you to stress out about there being a natural log here, because really all this is implying is that it's just log base e, and if e stresses you out for some reason, it's literally just there to say that these are logs with the same base. So that's why we can use a lot of the properties of logarithms on these because they have the same base. That's really all there is. It's not that deep. So let's take a look at this. We can distribute the x plus 3 into the ln 2. So let's do that. We're going to get x ln 2 plus 3 ln 2. And then this 2x ln 5 is just going to stay as 2x ln 5. But wait a second. According to the product rule, I thought that you would have to multiply these two. And I thought that the x was supposed to be in front of here, and the 3 was supposed to be in front of here. You're completely wrong. But it's okay, I don't blame you because it is very confusing. Now, let's go on a quick side quest here. Now, why does x plus 3 times ln equal x ln plus 3 ln and not ln x times ln 3 like we learned in the product rule? This equation works because it follows the general distributive property of multiplication in algebra in general. It's not a logarithmic rule specifically. So that's why you can just distribute this like a normal algebraic equation. The ln here just acts as a single constant, and the equation is just an algebraic expression. So if I put the x plus 3 in the back here, it's completely different to having the x plus 3 in the front. By having the x plus 3 here, you're implying that this is the answer. This does not mean x plus 3 times ln. This means ln as in log base e of x plus 3. It's completely different. So if it were to be this way, then yeah, you would apply the product rule where ln x times ln 3 equals ln x plus 3. So yeah, now you know. This is something that a lot of people mess up really easily, so make sure you remember this. Anyways, back to the problem. Alright, and from here we're just gonna do some basic algebra. Not really much properties of logarithms that we're gonna be using here. We want to get the x on one side, so we're gonna move the x ln 2 to the right by subtracting it on both sides. So then we're gonna be left with 3 ln 2 equals 2x, and also you don't really need the parentheses in the 2x. 2x ln 5 minus x ln 2. We can grab the x out of both of these, and from here you just divide each side by 2 ln 5 minus ln 2, and then you'll be left with x alone on the right side. And so that gives us our answer for x. X equals 3 ln 2 over 2 ln 5 minus ln 2. Now, you can simplify that, but we're not going to be talking about that. Just an answer like this will work. Alright, and that's really all there is to cover about the properties of logarithms. In the next video, we're going to be talking about graphing logarithmic graphs, because as I've said repeatedly, logarithms are basically the same thing as exponents. So yeah, it's going to look really similar. So yeah, I hope you learned something new from this video or got some good reviewing, and I'll see you in the next one. Now this square tells us that there's 4 of these 2 times 2. This square tells us that there's 2 of these 2 times 2 times 2 times 2's times 2's. This 2 tells us that there's 2 of these 2 times 2 times 2 times 2 times 2's.